What's up, everybody? Pythagorean theorem on a coordinate plane today. Finding distance between 2 points on a coordinate plane. Not too bad. It's really just using more Pythagorean theorem. We're on page 402, 403 in your book. Example 1, finding distance on a coordinate plane. Using the Pythagorean theorem.
How can you use the Pythagorean theorem to find the distance between any 2 points? Think about this question during the lesson. Jim and Thomas want to go from the haunted mansion to the clown tent. Jim wants to walk on the marked paths, but Thomas says that walking along a straight path from the haunted mansion to the clown tent is the shorter path.
He's right.
How can you use a coordinate plane and the Pythagorean theorem to represent and find the distance Thomas will walk? Plot and label the locations of the stars on a coordinate plane. Use the stars as 2 vertices and draw a right triangle. The 2 legs of the triangle intersect at the point with coordinates 1, 1.
Okay, so you can see, and I know it's hard to see here, but basically we can draw on any 2 points on a coordinate grid. We can always draw a right triangle by drawing a vertical line through the one point, a horizontal line through the other point. That is going to create a 90-degree angle, and to use the Pythagorean theorem, we've got to have that 90-degree angle.
Use the Pythagorean theorem to find the distance between the 2 points. Substitute the known lengths. Add 2 squared and 3 squared, which is 13. Take the square root of each side of the equation. So, C is approximately 3 61/100.
That's it.
The distance along the map between the haunted mansion and the clown tent is approximately 3 61/100 centimeters. Jim walked along the marked paths from the haunted mansion to the clown tent. How far did Jim walk?
Select your answer.
Okay, now on this one, we just have to look at the scale. There's a scale giving to us right here that says each centimeter is 500 feet. Okay? Now, we can calculate how many centimeters he walked. Now think about it. He walked on the marked paths. He walked down this way, and he walked over this way. So he walked down 2 centimeters and over 3. Well, again, each centimeter, 500 feet. So these 2 centimeters, 500 plus 500, this is 1,000 plus another, okay, and I'll write it here. This is 1,000 feet, because again, each grid block represents 500 feet. So down here, he walked 1, 2, 3 of them. Each one is 500. That's 1,500 feet. So how many total feet together? He walked down 1,000 feet and over 1,500 feet. Add them together. You can see it. That is bingo.
Now, use the map scale to find the actual distance. 1 centimeter is to 500 feet, as 3 61/100 centimeters is to x feet. Thomas walks about 1,805 feet, which is almost 700 feet shorter than the 2,500 feet Jim walks.
Okay, and that's just by using what's called proportional reasoning. You guys did a lot of that last year in 7th grade. Hey, we know the scale is 1 centimeter to 500 feet. We know from what we found in the Pythagorean theorem, he is walking 3.61 centimeters on this grid. Well, cross multiply, solve for x, it comes out to be the 1,805. Okay, and again, that's the distance from here to here. If he walked on the other path, remember we said it was 2,500 feet? So a lot less distance. All right, next one says, hey, find the distance from point A to point B. Okay, well, that's the distance from here to there. Well, in order to find the distance on a coordinate plane, draw a vertical line through one point, horizontal line through the other point. Those two are going to meet at a right angle. Now, can we find the length of this leg? Yeah, this leg is 2 units long. Can you find the length of this leg? Yeah, this length is 2 units long. Hey, find the length of the hypotenuse using the Pythagorean theorem. So, A squared plus B squared equals C squared. You guys have seen and done this enough. Okay? A and B are your two legs. So 2 squared plus 2 squared equals C squared. Square them and add them together. Well, this is 4, this is 4. Together it makes 8. So 8 is equal to C squared. We then have to find the square roots of both sides, and that leaves you with C to equal, okay? We could say exact answer is square root of 8, or if you approximate it, well, the square root of 9 is 3, so the square root of 8 is going to be a little bit less than 3, and it comes out to be approximately 2 and 83 hundredths, 2.83, okay? There you go. Let's take a look at example number 2. Okay, on example 2, now it's just asking to find the perimeter of this triangle. So to find the perimeter of the triangle, we have to find the length of each side and add the 3 sides together. Perimeter is just the distance all the way around. So, step 1. Okay, now it says use absolute values. Folks, if we're on a grid, just count the grid blocks. How long is this side? Or what's the difference between 4 and 1? 4 minus 1 is 3. This length is 3 units long. This length, okay, we are moving horizontally. So what is the difference between -2 and a +3? Well, if you found the difference of -2 and a +3, that is 5 units. Or just count 1, 2, 3, 4, 5. So we have a right triangle with a leg of 5 and a leg of 3. Step numero 2. Why won't it let me select step 2? That stinks. It won't let me select step 2. Isn't that a shame? Either way, you guys know what to do. Well, let's do it, okay? If we know the length of 3 and the length of 5, this side is 3, this side is 5, we got to find this length. Okay, so 3 squared plus 5 squared equals C squared. Again, we know the 2 legs. Square them and add them together. This is 9, this is 25. 9 and 25 together, that's 34. Is equal to C squared. So, to find the length of C, we need to find the square root of 34. Bingo. 5.83. Approximately. 5.83 is the length of this side. So, to find the perimeter, there he is. Add the 3 sides together. Well, what is 3 plus 5
8
plus 5.83?
13.83.
Okay, add them together. That's perimeter. Add the 3 sides. 13
It's like on your calculator.
and 83 hundredths.
Is
There's your
that
perimeter.
centimeters? What is that?
That's not given. Units.
Units.
Units, everybody.
Okay.
Units.
Good job.
Okay, find the perimeter of this triangle with these vertices. Now, they don't give us a coordinate grid. Oh, well. Hey, let's just make one. How about that?
Yeah.
You like that idea? Over 2 and up 5. Okay, that's going to be around here
Roughly.
somewhere.
We don't have to be super accurate here,
Over
folks.
2 up 5.
Yep.
This point is over 5 and down 1.
Yep.
Over 5, down 1. And this point is over 2 and down 1.
Ooh.
Oh,
Okay.
my.
That looks like a right triangle.
Well, I mean, watch this. I'm going to connect these together. That sure looks like we created a right triangle.
Uh-huh.
Okay? I'm going to expand that right triangle over here.
Wonder if we could figure out those 2 legs.
Okay? Well, we have to go. What's the length of this side? Well, we started at 2 and we moved horizontally to 5. Well, from 2 to 5. That's 3.
Yeah. 5 minus 2, guys.
Yeah, just
Distance.
take 5
Subtract.
minus 2. Okay? Vertically, to find this leg. Well, we started at -1. We ended at a +5. What's the difference between 5 and -1?
4?
No.
No.
5 and -1. That
3.
is a difference of 6. Okay? That's a difference of 6. Well, what's this side? That's where we use the Pythagorean theorem, my friends. Okay, a squared plus b squared
I feel like there should be a song.
c squared squared. Okay, so 3 in there for A, 6 in there for B. Again, doesn't matter where you put it. Okay, other than A and B. Square them, let's add them together. This is 9, this is 36. 9 and 36 together is 45. Okay, find the square root of 45. So I find the square root of 45. Bingo, this comes out to be approximately 6.71. Okay, so this side right here, 6.71, approximately. Now, questions asking, find the perimeter. So, take the 3 sides. 3 plus 6 plus 6.71. Well, this is 9. 9 plus 6 is 15 plus 71 hundredths.
15.
Okay, is going to give you 15
Point.
and 71 hundredths.
Yes.
Okay, Mr. Freaky wants you to take a quick look down there at example 3. Say bye-bye to it.
Bye-bye.
Okay, that's all we got. Finding distance on a coordinate grid. Folks, draw a right triangle. Okay, anytime we can create a right angle, we can use the Pythagorean theorem. Check you out on the key concept, page 404. See you soon.